Hey guys, it's David from 3D Make It, and today we're going to be going through how to install the E3 Turbo from Big Tree Tech. Let's go! So today we're installing the E3 Turbo on an Ender 3 Pro. Why did we pick an E3 Turbo over the Creality 4.27 board? The simple reason is we wanted UART. UART is important to me because I don't like flipping over my printer to change VREFs and work on it. Once it's in there, I don't want to turn my printer over again. This board also supports sensorless homing just by a jumper pin, so if I ever wanted to take those switches off and just go sensorless, I could. It also has expansion on it for the NeoPixels, UPS, wireless, BL Touch native. The 4.27 board, in all fairness, from Creality does support a BL Touch now. The last feature this board has that I'm not going to be using right away would be the ability to add another Z lead screw, and it has a port on this board ready to go. All in all, this E3 board is a drop-in replacement to what's in the Ender 3, which is a 114 in mine here. So we're just going to take it out, put this one in, and then we're going to work a bit on firmware. We'll show you some tips along the way. So let's jump into it. So before you even take screws out of the case, make sure you unplug the printer from power so we don't have things go poof, green smoke, burning smell, end of fun. So get the panel off the Ender 3, there's 3 screws on the bottom of the printer, and there's also one on the top that you'll have to take out. The screw that's farthest to the center of the printer is longer, just so you're aware and you remember where it goes. On an Ender 3 Pro, you have to tip the printer upside down to get to it. On an Ender 3, the 3 screws are on the top, but you'll still have to get underneath to get that last screw out. When you're done getting the screws out, you can come here and just unplug this fan because it's not going to be in the board anyway, which releases the whole top cap and you can just set it aside. So once we look at the board, we can see that all of the cables are labeled. So they have these little stamps on them, which is great. So we don't have to really worry about labeling these ones or even our end stop switches. The part cooling fan is the blue and yellow. And so then the hot end fan is the other, the black and the red pair, but we'll cross that bridge in a second. The only other one here, and it looks like they've changed it up a bit, the thermistor wires used to be the same color, which made it fun when you were unplugging everything and plugging it back in. But the black is for the bed, so black bed, and the white is the hot end. So black bed thermistor, white hot end. So it's pretty easy. So we're just going to get to unplugging all of this. We'll unscrew the terminals, and then we're ready to put the new board in. Once the new board is in, we'll go ahead and put the heat sinks on that came with the packaging, as well as the SD card will go in. It came with the jumpers to do sensorless homing, but we're not using those right now, so they will go back in the box. Just so I don't lose it, SD card's gonna go in right now. The nice change they've made to this board is the trace around those heat sinks is a little bit bigger, so you're not going to have to worry about hitting other circuitry with those aluminum heat sinks. So just a small note with the SD card, once it's in there, I leave it. I'll do my firmware uploads and all of that using a USB cable to the computer because the board will show up as a USB drive. The likelihood of that spring breaking on these guys, I've had a few go on other ones, so they're just tape flush because the spring doesn't go back in anymore, so I just leave it in there now. To terminate the extruder to the controller, as well as what we're going to use for the hot end cooling, these green blocks come right out of the board. You can terminate the cables in them and then plug them back in. That way you're not trying to work a screwdriver diagonal in that little tiny space. So, old board out, new board in. I've got this neat little graphic here, so let's just go through some of the wiring stuff quick and then we'll jump into firmware. So let's talk wiring really quick. The old board's out, all the wires are there. I like to start with the power in wire and then I work my way down through the extruders and then come back and do the hot end wiring. Of note, when you follow this diagram, you will get an exact replica hookup of your other Creality board that came out. I'm going to change it up a bit and we're going to talk about what we changed when we hit the firmware in a second here. But instead of the hot end fan going up to this top BIC block here, we're going to come down and we're going to actually use this extra extruder terminal to use it as a CS auto fan to actually make it quieter when it's just idling. It makes a whole lot of difference and it's easy to do. So I'll leave this up for a second so you guys can take screenshots if you want and get ready to hook up that wiring. So it's the moment of truth. Everything's in. We're ready to turn on the printer for the first time. Hopefully we don't see smoke. So here we go. We'll turn it on. And I got a screen. I got a BP light. That all seems pretty normal so far. Let's see what we got going. So this is just the stock firmware that came on the board. We're going to be updating it in a second, but you can see here that my thermistor 1 and my bed are reading room temperature, which is good. We'll just keep an eye on them for a second there. And other than that, it's just wanting to be home. So it looks like we've done it. There's no blue smoke and we are good to continue on to the firmware section. Normally, when we work on firmware on 3D Make It, we always go to the Marlin Firmware page to grab the latest, freshest build of Marlin. But in investigating this build and this firmware for this board, I've discovered something amazing. So let's jump on over to the Big Tree Tech GitHub for the E3 Turbo. To get to the E3 GitHub, I just Googled Big Tree Tech E3 Turbo GitHub. Easy peasy, first link, let's go. So inside here, there's a few spaces we're going to look, but the first one is firmware. Inside their firmware, you can see here that they do already have some pre-configured stuff, and they actually have this bin file all ready to go with Marlin 2.0.7.2. Amazing, good stuff, love it. It's the newest version of Marlin, and it's awesome when manufacturers throw the new version of stuff on because you know it's the best at the moment. We're going to actually grab this and download it. So if we go into the master here, we're going to download this file and basically it's going to go give us Marlin that we need. So we'll come back to that in a second. The other thing that we're going to download other than this firmware file, so we're just downloading the firmware folder in the master. We're going to go back and we're actually going to look at the hardware and then we're going to look at the pin out and we're going to use this to configure the other pin that we talked about. So the other extruder, we're using it as a CS auto fan for our hot end cooling so that when the hot end gets hot, this will turn the fan on. When it gets cool, it shuts it off, way quieter. So if we look here, we can see that HE1, which is the spare one, is 2.4. So that's something we're going to reference coming back to, but let's get those files downloaded and then we'll get everything into VS Code. So once all of that's downloaded, just right click, extract the folder. It's going to bounce out, extract to where you are, and then we're going to have our folder with our firmware in it. The reason that we want to bounce to like a folder outside of this long string now, so once we get it extracted, we're going to go into the Big Tree Tech folder and we're going to go firmware and we're just going to copy this out. And then we'll go back to downloads and paste it. So what we're doing is just removing a long file chain from it. That'll let the compiler have an easier time, if not work better, as we're going through and compiling it. If the file name gets too long, it'll just error out and it won't work very well at all. So just before we jump in and open that file that just extracted in VS Code, open the project up, I have a bit of a checklist here. It's just a run through of stuff that I like to check just to make sure that it's right. In this case, we know that we're working off an example again, although Big Tree Tech made this very good config for us. So if we just go through configuration H, we're going to look for baud rate, serial connections, cosmetic stuff, build volume, jerk acceleration. It's all here. Motion, steppers, which direction they're going. Does everything look okay? In configuration advanced, we're going to be setting some auto fan pins, and that's because we're using that extra extruder now for our fan, which is great. It'll make it nice and quiet. And then we just have some trinamic stuff to double check, make sure everything looks kosher there. And we want to make sure advanced pause is on as well, because nothing is worse than trying to pause your print and then the extruder hovering over while you're jamming, filling it in. So let's just get that advanced pause on. So on with the firmware show. We have our list, we're ready to go. It's fairly straightforward. So what we're going to do is here's our Marlin from our zip file here, so we're going to open that. Now it's worth noting that inside this Marlin in the platform IO file, we can see that it's already set to the environment for our board, which means this project is already built and we can just open it without importing it, which is good. So when we come into VS Code, we click our alien and we click open, and then from the open screen, once it loads, we won't pick import project. We're going to actually pick open project. So here's open project. And then from here, we will just navigate to our downloads folder where we are keeping this. So right here, and then here's our E3 Turbo. We can click in. Now remember, when you're importing or opening projects, if you're opening a project, you have to have that platform ini file showing in this window when you click open. So only navigate to the first folder. When we click open, it'll pull it in. And interestingly enough, it might show us some errors to start with, but we're good. We're ready to go. So we can close this welcome window and PIO. We'll start with the configuration.h. In configuration H, we're just going to check our cosmetics things and baud rates first. So as we come down, all of this is fine. It's pointing to where our example file is if we wanted to find it. We have the version, which is good. Here's some cosmetic stuff. The author, we're going to leave it as Big Tree Tech. I'm just editing it. This is not for an Ender 3 though. This is for the Pro. And it's splitting hairs. They're fairly well the same printer, as we all know. Show boot screen, so that'll make sure that that Ender logo pops up for us, which is nice. Serial parts are already set for us, -10, so that is amazing. Baud rate 115200, and again, make sure that you set 115200 if you don't see it. If you're running the TFT screens, some of them will stop communicating if the board's running faster than that, so 1152 is great. Motherboard's already set for us, so the BTT SKR E3 Turbo. That's right, one extra T for turbo. I'll change this again nitpicky, but hey, I like to nitpick. And we got Ender 3 Pro. So everything else looks cool here. We've got extruders, all of that stuff. So let's go to the first one, and that's the build volume. So on our checklist, build volume was number 1 after all, a couple other number 1s. But we could see here that this one has it configured correctly. So we got 235 by 235, which is the full build volume of the build plate, and 250 going up and down on the Z there. So this is configured correctly, so we can move on and check our acceleration and jerk next. So you can see I'm just using the search window here. Acceleration. I can type, I swear. There we go. So default acceleration, this looks good for an Ender. The last value that is very, very high is the extruder. So that is normal to be high, but it is not out of bounds. So we're good there. The next thing we can look for is our jerk and acceleration settings. So here's some default acceleration settings, 555, really good, really good. If we just keep going down, jerk's right there, so it's really easy to check. But if you get lost, you could always search for jerk up there. So we can see here that we're not using classic jerk, which is good, frankly. We're defining a default jerk value because it might be used later. Linear Advance actually uses it to fill in the blanks, so that's why we use it there. And then we can come down and we can see that S-curve acceleration is on, and as well as, you know, some of the other settings. But after acceleration, S-curve, that's the last part in this section that we're going to look at. So once we get those ones down, it's basically we just need to double check our drivers. So I'm going to go TMC 2209, and you see it brings me right to the section here. And then if we scroll up just a bit, we have our end stop and thermal protection settings that we wanted to check as well. We didn't skip them, they're right here. So here's the safety stuff that's enabled. It's just I do the drivers and the thermal at the same time because they're so close together. So when we go back down, we can see here that all of the drivers are set correctly. So we have 2209s and not in standalone. That means we'll be using UART, which is great. The other one we're going to look for is just that the drivers are going to go the right way, which is important. So for 2209s on this Ender 3, we're going to be looking at inverting the X and Y. So both those values should be true, and as well as the extruder should be true. So once we've got all that verified, we're done in this file, which is sweet. We are done. So we can go to config.advanced. So here we are in config.advanced. It seems like we've never seen this file before. So if you look up for in config advanced for linear advance, it's actually in here. It's called lin advance and it's defined. It's bounced around a few times here and there, so now it's in here. So we'll have to make a mental note on your checklist that it's moved over here. Now, the other thing we want to do is set some fan pins. Now, the ones we're actually looking for are called auto. So if we search for auto fan, ta-da! And we already have one fan pin that's auto, and we talked about that before. So that fan pin is the one that's connected to the the case cooling fan when we plugged it into the board. So that one's good. The other one that we're going to use is the extruder number 2, and we're going to use that one for our hot end. Now we're going to have to come and define this pin, which is okay. So I'll just call it fan pin 2. And while we are doing this, so we're going to put our checklist on pause briefly. We're going to go into the source on this side here. We're going to go to pins. We're going to look at the LPC 1769, and then we're going to come to the turbo. It's right there, which is good. And you can see here, I kind of have the section brought up already. If you don't, it's on line 162 now, but you can also search the word fan, and it will bring you right here. So there's a few things we're going to do. So we want fan pin 2 defined. So we know right here that fan pin number 2 is going to be defined. So we're just going to add the line, change it to fan pin 2. We know for a fact actually right now too that heater pin 1 is the one we're using. So if we comment that one out, that means that's no longer used. We looked it up in the diagram before and it was P204 or P2.4. So we know this is correct. And we can just paste it in there. And once we save that, we've now defined that pin, which means we can use it in the other section in configuration.h over here. So now all of these will work. The other cool thing that this board has that we might not have mentioned before is the fact that it has a thermistor on the board. It has a thermistor to basically tell you how warm your board's getting. It's great if you want to put it in an enclosure. So what we're going to do is come up here on the temperature sensors, and you can see here that they've defined pin 1.3 or 130 I should say right here as the onboard thermistor, but they're not using it. So we'll enable that. So I'm going to hit enter. I'm going to add the line temp chamber pin 130. So what that will do is let us use the chamber thermistor as the onboard thermistor and give us some feedback on the temperature of the board. So that's pretty neat. So while we're doing this, since we've added this section, let's just pop back to configuration H. We're going to search the word thermistor. We'll go one more. And we can see here that we have our hot end thermistor, we have a bed thermistor, and now we have a chamber thermistor. So it's 100K thermistor, so I just used the default value for 1 there. So we'll just save that. But now when we compile this, it's going to give us the onboard temp, which is sweet. So we have all of that saved in our pins, and that's good now. We're done in that file. We can come back to our config advanced checklist now. So we've set our fan. We've set our fan to pin 2 right here. The next thing we want to check for is the TMC debug mode is on. There's not much point in using UART if you're not going to use all the functions that UART gives you. So when we search TMC debug, we're just going to comment or uncomment that line to get that working. The other thing we're going to do with our TMC drivers is we're going to check the VREFs to start with. So to find that section, you can search for has trinamic, and it's already found it there. So here we have the first section. We probably want the second one, so let's just get rid of that. There we go. Try. Yeah, much better. So it has trinamic. And so this section here, you can see her in the right section because it has the TMC 2130s, the 2208s, everything's listed up here. So it's right around line 2267 right now, but probably in the next release it won't be. So we want to make sure that our X, Y, and Z steppers are all set between the 580 and 600. It's splitting hairs. Either one will work fine. I use 600 on most of my Ender 3 stuff, but I'll leave 580. It's there. And then on the extruder, so you can see down here, we have the extruder. It's going to be a little hotter. It's 650, and that's just because it needs more torque to push out filament. Everything else we can leave for now. And the nice part is in UART, we can actually change all these settings after if we get bored or we really want to experiment at how fast and hard we can push our printer without those steppers catching fire. So the other section is hybrid. So if we type the word hybrid, we want to make sure that hybrid threshold is off, because hybrid threshold is what switches between stealth chop and spread cycle. So if we do a search for spread cycle, we can see here, if we don't define our stealth chop, it will automatically use spread cycle, which is the louder of the two. And we don't want to go into a hybrid mode where when we go faster, spread cycle turns on. It gets a little noisy and annoying. The very last thing we're going to look at is the advanced pause feature. So advanced pause is it's like line 2087 right now, and just make sure it's enabled. You can update the settings, but the default settings will work for you just fine. Lastly, we're just going to hit the build button. We're ready to build. So I'll meet you on the other side. Okay, so the first time I'm going to flash firmware, I will take the SD card out. I'll break my rule. The spring seems okay for one go anyway. So I've plugged it into my computer. Here we go. Here's the firmware cur file that's on it. To upload the new firmware to the printer, all we need to do is go into the directory we were working. So that's this Marlin config. And then we just need to go PIO, build, board name, and then we're going to find the firmware.bin file. Drop it on the SD card, and once that's done, we're actually going to just go safely eject it, and then we should be good to go. So let's pop this out and turn on the printer. Okay, so the SD card went back in, we turned the printer on, and yeah, life's happy. We've got 3 thermistors at the top just like we configured. One that's about 46 degrees, 21 at the bed, and 31 in the control box. It's 46 because I just had it on. I wanted to test the auto fan. So let's turn that thing on to 50 degrees again and see if we can't see that fan at the bottom right there. Well, I guess it's at the top of the screen for you guys. But once we hit 50 degrees, that should spin up and we should hear the case fan spin up too. And there it goes. Awesome. So we know that our firmware worked. We had good flash because we've got all our stuff on the screen. We can do everything. We can heat the chamber, or see the chamber heat, sorry, and we can heat the hot end. Life is good. I'm happy. Now just on to printing. Well, there you have it. The Victory Tech E3 Turbo installed in an Ender 3 Pro. Firmware configured. The whole thing took maybe 15 minutes. I want to thank you guys for watching. Like, share, subscribe. You guys are all awesome. I hope you have a wonderful time off, as good as we can have in 2020. We'll see you next year in 2021. This is the last one. Until then, have a good one.